Hello everyone, I am Yash Gulati, a BTech CSE student at LIET, and today I'll be solving the 50th question of Leetcode, that is making the power function myself. Now I have two approaches to solve this question. Let's start with the first approach, that is a recursive approach. First we have to tackle all the cases, that is all the values r n can have. First is if it's equal to 0. If our n is 0, we return 1 because anything raised to the power 0 is 1. Now another case we can have is if our power is even. So what we can write is if n mod 2 equals to 0. If our remainder when divided by 2 is 0, that means our number passed is even, and we can just return my power and pass the value x into x comma n by 2. What we did here is reduce our calls by half essentially, because if let's say we have 10 as a value of n and we reduce it by 2, then we have 5 more calls left, and at the same time we have squared the x value. So it's like we are performing this operation ourselves and reducing it. Next case we can have is n mod 2 is equal to 1. Now if our n mod 2 is equal to 1, we can make it even by multiplying it by x and reducing the power by n. What we are aiming for is we are trying to make our power even so that we can reduce the calls by half by running this part of the code. Now we have tackled three cases: if our value is 0, if our power is n, and if our power is odd. Now the third case which we have to handle is if our value of n is less than 0. Yeah, exactly, if our value of n is less than 0. So my bad, let me just put it here. Yeah, in that case what we have to do is we have to first convert our n to a positive value and then simply return 1 divided by my power x comma n. This I think should run properly because we have tackled all the cases. Oh, that's the error non-void function. Oh, let me remove this. Okay, all our edge cases now run. Let's try to input a case ourselves. Let's make this power as 1. Yeah, I guess that should work. Nah, numerical value has exceeded. Let's make it 1000. Okay, 100 it is, guys. Let's just submit it. 0 ms. This solution is good, but due to the call stack that we are making of the recursive calls, we can make it better by reducing our space usage. That approach will be an iterative approach. Now in that approach what we can do is first we can take a flag and set it to true. What we are doing here is we are assuming that our value passed is already true. Now we will check if n is less than 0. If our passed value, that is n, is less than 0, what we have to do? We have to make n as positive. So let's make it positive by a binary operation because they cost less to the compiler, and set our flag to false. Okay, now we have tackled through the negative values. All we have to do is check if our n is less than, while our n is greater than 0. We have to run this part of the code, that is if power, oh my bad, if n mod 2 is 0, what we do is reduce our n value by 2 and we square the number passed, that is x. X will be equal to x times x. This is the case if the value passed is negative. Now if the value passed is positive, we have to reduce the power, that is n, and multiply answer variable with num or x. Now to store this value, we need our answer variable. As our solution demands a double answer, we will set our answer variable to double and its default value as 1.0, or we can take it 1. The next thing we have to do is check whether our flag is negative or positive. If it's positive, then we have to return the answer variable as it is, or else we have to return the answer variable as 1 divided by answer. Let me just remove this test case. Okay, what we are facing, 1 point this flag, we check. Okay, let me just go through the code and verify what's wrong with it. Our power is n, flag equals to less than 0, we set it true. For flag we set it false. When we go to answer, while n greater than 0, we run the code. If n mod 2 equal to 0, reduce n by 2 and multiply x2. Oh, here is our issue. Yeah. Now this should work, but there is a edge case that I would like to show by submitting this code. As you can see, what happened here is when we took the complement of our variable, that was minus of that was the minimum value of integer. Taking a complement sets it to the maximum value of an integer, and adding 1 to that is not possible. So what we can do is we can take another variable and write it as n and set our given variable to power, let's just say. Now taking log of long n equals to power, we can solve this question. Now this shouldn't be a problem. Yeah, easy submit and solve. It's showing it's a slow solution, but it's not. Let me show you these side by side. Which was ours? Here it is. These are the two approaches that I used to solve this question. This one, the recursive approach, we tackle each and every possible value of n and make a function call for it. And this is an iterative approach where we tackle the negative values first and then do the same thing as our recursive approach, just in an iterative manner to reduce space complexity. That's it for this session, guys. I'll be back with another solution. Thank you.